to give us the graph of f of x. One thing you can do on this graph of f of x is you can add an asymptote at y equals 0 and an asymptote at x equals 0. The first thing I would do in this equation is I would rewrite it so the y is by itself. And I notice that it is already nicely in factored form. So notice that we have, I'm going to label it right now, this is a horizontal stretch. It's going to multiply because x's are liars, the x's by 2. The plus 1 is a horizontal translation. X's are liars, that would go 1 to the left. And the minus 4 is a vertical translation 4 units down. So I like to set it up so the y is by itself. I also like to set it up to make sure that it's in factored form. And we want to sketch the graph moving forward. So this is your reciprocal graph. This is the 1 over x graph. In fact, the most important point, they've labeled 2 and a half. I probably would use 1 comma 1 and negative 1 comma negative 1. With the reciprocal graph, those are the only 2 points you need, but you also need to look at what happens to the asymptotes. So let's just do the points first. We have 1 comma 1 and negative 1, negative 1. Since we have stretches and translations, I will do all the stretches first, which the only one is that your x value is getting multiplied by 2. We have 2 translations, 1 to the left and 4 down. So first, starting x by 2, y values aren't going to change. Double check them in your head. Then 1 to the left, 1, negative 3. 4 down will be negative 3 and negative 5. So that's where the points are going to change. But we're also going to take a look at what happens to the asymptotes, which are x equals 0 and y equals 0. And something interesting happens is that the stretches and compressions, we can just do one big arrow here. Because they start at 0, if I multiply my x by 2, do you see it still would be 0? If I multiply y by anything, it's still going to be 0. The only thing that's going to affect these asymptotes at 0 is if we move it left, right, or up and down. The vertical one, here it's pointing straight up and down. If you move that up and down, it makes no difference. The only thing that's going to affect the x equals 0 is if you move it left or right. What are we doing? We're going 1 to the left. Does it make sense that this asymptote is going to shift 1 to the left to x equals minus 1? Because it was here, and now it got shifted 1 to the left. What about the y? It was at 0, and we're moving 4 down. It's going to change to y equals negative 4. Now, sometimes your textbook is going to say, hey, draw it on the same graph. If it says that, I would tell you to ignore the textbook at that time. It gets too busy sometimes if you draw too many things on one graph. So instead, we're going to draw this graph separately. And we're going to start by drawing our asymptotes. So we know that our y1 is at negative 4. And our x1 is at negative 1. We can plot our points. We have a point at 1, negative 3. And we have a point at negative 3, negative 5. Draw your Draw your graph towards your asymptotes. And we have our final graph. It asks for the domain and range of the original one. The original one, I would just write x can't equal 0, y can't equal 0, and then on our new graph, now x can't equal -1, and y can't equal -4. And your homework is brought to you by Slurpee.